right, welcome back everyone. Up next, we have James with Intro to Certificate Management. Go ahead, James.
Thank you. Well, welcome back, everybody. This session, I'm going to talk to you about the SSL and TLS certificate management on your ZVM system. We're going to walk through some terms and basically an overview of what this is all about. Talk about why you want to set up this SSL or TLS security on your system, and then using what's provided to you to manage your certificates and your secure connections. Now, securing your system, this includes a lot of technology that all works together to make it work, to make it functional. Things like TCP/IP, open extensions or BFS, secure sockets, cryptography, data encryption, cipher suites, all of those things that go into securing your system for secure transmission of data. It is a complicated collection of topics. Any one of those topics is multiple sessions within themselves. So if you're planning to be a cybersecurity expert, and that is going to be your job, a lot of those things will probably become a lot clearer to you as your job goes on. If you're a ZVM system administrator, those topics can be a challenge to figure out, especially at first, and it takes time to learn them, even to understand the basics. And really, for a system administrator role, you want to understand at least some of the basics of those topics. So common terms in this particular space. You're going to hear these or see these throughout the discussion on this session and when you're working with SSL security on your own systems. SSL, it stands for Secure Sockets Layer. So it's an encryption-based protocol. It's what was originally developed for securing data transmission. TLS, this is a newer term, but it is also most used nowadays for secure transport layer security. But most people will use TLS instead of SSL, but they generally mean the same thing. But TLS version 1.3 is currently the latest version of the transport layer security out there. ZVM currently only supports version 1.2, and version 1.3 will be here soon. Again, SSL TLS or SSL and TLS, those are most times people will use them interchangeably, but it means the same thing. It means a secure transport or secure data transport. Certificates or TLS SSL certificates or secured certificates, pretty much the same thing. That certificate will contain one or more server or host or service identity and a public key. So this is what is used to define and set the security on that system. The public key, this is what the remote devices or applications will use to verify that server's identity. Certificate authority or CA. This is a trusted organization that confirms and verifies that the information that's being provided to them on behalf of requesting a certificate and public key is really them. So for instance, if you go to our website using HTTPS, velocitysoftware.com, the browser determines, is it really them? Is it really Velocity Software? By looking at the certificate and key. Now, just having a certificate doesn't necessarily verify that the target host is trustworthy. This is where the CA comes in. That CA and the CA chain determines the trust level of that certificate. A couple of other terms, you'll see FIPS, the Federal Information Processing Standard, and NIST, National Institute of Standards and Technology. Those are used when you start looking at some of the cryptography and some of the cipher suites that are available. But really just to be aware of what those terms mean. Now, some user IDs or utilities that are on your system that you want to know about. GSK admin. Now, GSK is IBM's Global Security Kit. It's the shortened version of that title. This is how your ZVM certificates and key database are managed. This is the user ID you're going to use to do all of that work. GSK KYMAN is the utility used for doing that work on the GSK admin user ID. So anytime you want to do anything with your key database or your certificates, that's the utility you're going to go into. A new utility that's being provided within GSK admin or the TCP/IP product is Cert Manager or Cert MGR. This new utility allows you to report on and now manage certificates on GSK admin. Now, why do you want to secure your system for SSL TLS? In today's world, as you may have heard in the RACF session, but you really need all of your systems to be secure. And with access over web browsers using HTTPS or using FTP file transfer protocol, you want, and Telnet being able to access the system through 3270 or TN 3270, you want those to be secure, all data encrypted, because you don't want any data to be accessible by anyone at any point, including and most especially login credentials. So the only way to do that reliably is to use and set up the ZVM SSL. I also mentioned that threats are not just external. If your systems are on the internet and people have access to your systems through a browser or TN3270, whatever the case may be, that's even more reason to secure your data transport. But it's the people inside that are a threat also, because the internal people can set up network sniffers. I mean, if they want to and they have the tools and access, they could be setting up ways to sniff your data and catch login credentials. Now, I'm going to walk through setting up ZVM SSL services. A manual you're going to want to have handy when you're doing this is the ZVM TCP/IP planning and customization, and pay close attention to Chapter 15, configuring the SSL server. This goes into a lot of detail, but it is good reference. The GSK admin user ID is what you're going to be logging on to do all of this work. By default, you're going to do a logon by and use IBM VM1 as the user ID and password to start working with it. It does have an installed profile exec that comes with the system, and it's going to set everything up for you to be able to use what's called the byte file system. And this is under open extensions or open VM. This is a Unix-like environment We're not going to go into a lot of detail on the BFS or open extensions, but if you're more interested, or you're interested, you can look at more data or more detail on that environment at a later time. Now, once you're logged on, this little 3270 icon is my indication that what I'm going to do now is go into a live demonstration of setting up your ZVM SSL key database and getting your first certificates started. Because the next few slides in this presentation, these are step-by-step processes or a simplistic checklist of items to do to help you to get started. What that means is you can use the checklist, the numbered items, to set up your own SSL key database and start your certificate requests. Now, on the system that I'm going to be using, this is in front of you is this is a test system. It is a system that I use just for this very purpose, and that is to test different things out, make sure security is working the way I need it to be, make changes and all those nice things to be able to do without having to touch a real active system. So this is the system we're using. I'm also going to show you that on this TN3270, down at the bottom area, there is a little black box in the bottom left corner. This is an unsecure connection to this system. So there is no data encryption whatsoever right now on this TN3270. And then a browser page. This is a web browser page to this system. And if you'll note at the top on the location bar, there is a not secure. So this site is also not secure. So let's get started and log on to GSK admin. Again, you're going to want to log on by VM1, IBM VM1, and enter its password. Now, when you first log on to GSK admin, you get the usual CP and CMS information, but pay attention to what now comes out when you tap enter to continue. The profile exec runs and it does the initial setup. It sets the CMS environment to access disks that it needs, sets up some PF keys for you, but then it sets up the BFS environment, the byte file system, the Unix backend environment that GSK admin is going to use for your key database. So it gets it all set up. The very first time you log on, you also will see the Etsy GSK admin directory is empty. There's nothing there. So this is a brand new environment. So the utility that I had mentioned is GSK keyman. You'll just enter that command and it will present you with a list of options. And what we want to do now is create a brand new database. So we're going to select option 1 and hit enter. We'll give it a name. And in this case, I'm giving it the name allcerts.kdb. KDB is key database. You can name it anything you want. You could take the default. The default in the examples in the manual is database. Name it what you want that makes sense to you. Now, I'm going to give it a password. This password, this is very, very, very important that the password you give this database you must remember, because if you lose or forget this password, you have to start over. Your key database is unusable. So be very aware. So it asks me to validate what I typed, if I can type it correctly. Okay. And I don't want the password to expire. If you choose to, you can. Um, Also, when this utility asks you to press enter to continue, you actually have to press enter twice. It's a tiny bit of a nuisance, but just be aware if you're just pressing enter, you have to actually enter twice. Now, the database record length, I'm happy to let GSK admin take the default. So we're going to continue that. Now, the database type. This is going to be driven by your security team or by what specifically you want to use in your certificates. There is a FIPS mode database, and there is a what I'll call a default normal mode database. FIPS is a different type of security. It has different requirements. So that's why at this point you have to set up your database for either FIPS or not FIPS. In my case, my certificates are not FIPS defined, so I am just going to click 0 to continue. Now my database, this database has been created. It has populated the database with the defaults and the settings that I've provided, and it's ready to use. So again, press enter twice to continue. Now you're presented with something to do with your database. And the very first thing we want to do is option 10. We want to store our database password on that directory. So I'm going to do that particular option. And it stores it in a file called the name of your database, in this case, all certs, and then an extension of .sth. This stored password file is very important in order for your SSL services on ZVM to be able to read the key database. You press enter twice again, and you're presented back to the main menu. The very first thing that you're going to want to do, most likely, is to create a certificate request. This certificate request is something that you do to define this system, this host, or a resource, and all the pertinent details for a certificate authority to use to issue you your first certificate and key. So option number 4 is to create a certificate request. So we'll start there. Now it's presenting you with choices to on the kind of key to use. This again is going to be dictated by your security policies and your security group. But in general, what I would recommend, at least for now, and especially for what we're doing here, I would say ECC is probably a reasonable key type to use. So I'm going to choose option 3. Now for ECC, it's going to ask you more questions, and this is where the background on cryptography and different encryption methods is kind of handy, because if you've never looked into these things, you really have no idea what either NIST recommended curves or brain pool standard curves, what are they? What do they mean? They're interesting to look into and understand if you don't already know what they are, or you're not being told what specifically to choose. Now, in my case, I know the NIST recommended curve is the best option for this for a lot of reasons, but this is the best one to go with. So I'm going to pick 1. Now it's going to ask me what kind of curve type. Again, details that you would have to dig into all of the curve technology for ECC to understand what that all means. I would recommend a 256-bit curve or higher, which is option 3, 4, or 5. So I will pick option 3. Now it's asking you for a file name. The file name is the name of the certificate request. And this is going to be important for later activity. So I'm going to call it new cert.request. And I'm just going to make it uppercase because it's just easier to see. Now it's asking you for a label. The label on your certificates are not only eye catchers, but it is an identifier for this certificate. And it's used for different reasons. So it's a 1 to 8 character label. Consider labeling your certificates with, say, a system identifier, something that makes sense for this host. For this example, I'm just going to call it sys1 cert. So that's my new label for this request. Now it's going to come and start to ask you specific questions that this certificate is going to protect. The first item that it asks for is what's called a subject name or common name. This is what exactly are we protecting? So I'm going to protect velocitysoftware.com, this host. That's the main host I want to protect. The organizational unit, that's an optional field that you may choose to put in or not, and we don't really need anything in there. The organization is definitely required. So you want to put the name of your company, most likely, your city, locality. Again, as the screen indicates, that is optional. I'm going to put it in just for identification. The state, also optional. Now the country is required. So you need your 2-character country code to put in. Now, if you have more things, more hosts, more domain names, more IP addresses to add for this certificate, because a certificate can protect multiple entities, you can put them in now. So you would enter one and it would step you through and ask you what you're adding, whether it be a DNS host name or an IP address, etc. For this example, I don't have anything more to do, so I'm going to enter 0 to continue. My certificate request has been created. So once that's done, it says press enter. You have to press enter twice. It takes you back to the main menu. And at this point, you can either exit or use option 3 and see what your request looks like. I chose option 3. You can see my sys1 cert request. I can select it by the number 1 and then do a number of different things on that particular request. There's nothing more I need to do here, so I'm just going to type enter or enter 0 and then press enter and exit from GSK Keyman. So now I have a certificate request saved in my byte file system. But where exactly is this byte file system? The way to get to that and see what's on that particular byte file system is to use, oh, I'm sorry, I have a routine called dir that will just run the command the OpenVM list file, and then the directory for the GSK admin. So it types out on the console all the files in that particular directory. And you can see new cert.rec. That file is in that directory. That is my new certificate request file. I need to be able to get to that file for the certificate authority. But before we do that, we want to be able to set all of our permissions for the key database and the saved password file to allow the SSL servers to be able to access them, to be able to function for the TCP/IP services. To do that, there are two commands that are used. They are it's an OpenVM permit command that changes the permissions on those files. These are exactly like what you normally would see in Unix or Linux for permissions on files. So I have a command that I called firms that runs both of those commands. So those commands were run, and if I type dir again, you should see the permissions now are changed. So group access to those files have read authority to be able to read the KDB and the STH files. So now that that's done, I'm going to switch back to the presentation temporarily and go down past what I've just talked about and talk about certificates. So you've got that certificate in the BFS, and you need to get that certificate request out of the BFS so you can actually use it and send it where you need to. Note, big note here, BFS is case dependent. So when you're setting up your request, if you had typed lowercase or mixed case, you have to remember that when you do the get command, the get BFS command, you will want to type in the case exactly as it was when you saved it. So if I do this command, the OpenVM get BFS, that will put new cert.rec into my CMS A disk as new cert file name and rec file type on file mode A. If you look at that file with Xedit, you're going to see it just looks like a bunch of letters and numbers and stuff. It looks, just like normal text. This is a plain text certificate. So that plain text content, it is base 64 encoded data. That data is what you're going to use or send to the certificate authority. You can actually copy and paste the contents of that data into an email or an attachment and send it to the certificate authority that you're working with. Or you can download that file that's on your A disk using your TN3270 file transfer process, or using FTP if you happen to have that available to you, and then email it as an attachment to your certificate authority. Now, your certificate authority might have their own specific requirements on how to get that data. They might accept an email, or you might have to go to their website and log in and paste it in. It depends. It just depends on your certificate authority. Now, once they have your request, they are going to do their job. They are going to go through the details that you provided and confirm that everything is legitimate. They may come back and challenge the authority you have to make this request based on the data in the certificate. request itself, because they are going to look for someone in authority for the company to be able to authenticate that this is a valid request. They do that because they don't want someone else external building a certificate for your company that don't have authorization to do so. So they're going to go through a number of validation steps to make sure everything is legitimate. And that's why they are considered a certificate authority. Once all of that is done, they are going to provide you a certificate and private key, and that will satisfy your certificate request. They also send along one or more what's called CA certificates. These identify them. They identify the certificate authority as the signer and provider of that certificate and key. So you normally will see a CA intermediate certificate and a root certificate. So a lot of systems already come with the root certificates pre-installed for you. So some of the most common ones like DigiCert or VeriSign, there are a few others that are pretty common. They come pre-installed, but some systems or some hosts that you're building for may not have them in there. If you're using an internal company CA, in other words, you have a group internally building your certificates, you will likely need to use their intermediate and root certificates that they send you, because those are uncommon certificate authority certificates. You want to import the CA certs first before importing your own key or certificate and key. The reason being is there's a hierarchy to this whole thing. The root CA certificate is the top of the hierarchy. It is the master record. This defines the certificate authority at the most highest level. What comes after that is the intermediate or signing certificate. This is what exactly signed your certificate and what kind of authority does it have. So in this example, DigiCert Global Root G2, that defines the root or master certificate. The DigiCert Global G2, TLS, et cetera, is an intermediate certificate that issued your certificate. And then your certificate is last in that hierarchy. So your certificate refers to the intermediate refers to the root. So if you have a new root certificate and or a new intermediate, add the root first or confirm you already have it, then the intermediate, and then your certificate. If you happen to forget, it's not a big deal, because when you try to add or import your certificate, GSK Keyman will tell you the signer certificate was not found. It'll explain you're missing something, and you can just go back and add the intermediate or root as needed. Now you're going to receive the files from the certificate authority in different various ways, depending on how they choose to get them to you. But one way or another, you have to get those files up to GSK admin. And this actually, in my opinion, is probably the hardest part of this whole process. Getting the data to GSK admin depending on the content of the files they send. So the first thing that normally you would want to do is review those files that they sent and look and see if you see those starting ending tags that you can actually read. If you can read those tags in the file, those are plain text, and they are much, much easier to transfer. If you can't read any of the content, then those are binary files, and you have to transfer them in a different manner. Plain text, just like your certificate request file, you can literally copy and paste the data into a new file on GSK admin. You can exit a brand new file, call it mycert CRT-A, and just paste in the data that you got from the copy of the certificate itself. Or you can upload the file and make sure you use ASCII character translation during the upload, because the data that you're sending up from your PC or laptop is in ASCII, and you want it translated into EBCDIC on the ZVM system. If you get binary text certificate files from your CA, you have to upload them using binary. No character translations at all. If you happen to miss that or forget, and the characters are translated in transmission, then the certificate's unusable and it can't be read. Now, once you get those files uploaded into GSK admin's 191 disk, you'll see something like this. So this is an example that I'm going to be walking through. I have a file called mycert CRT-A, and also a digit_CA cert. So that is the certificate authority certificate identifying them as the signer of mycert. You would have to put those files into GSK Keyman, or for GSK Keyman to be able to see them and use them. And again, I'm going to switch now into 3270 and walk through this as an example. On my A disk, I have those two files. So I've already provided the mycert CRT and the digit_CA intermediate certificate on my system. You need to run the open VM put command that is like this exec that I'm showing. It's just going to run the open VM put BFS with the file, and it's going to make a copy in the BFS file system for me. So if I run put next to this, that's the command it runs. And if I run put next to the intermediate, and that's the command it ran for that. So now, when I run the list in that BFS, I can see I now have mycert and the digicert certificates. So we're going to go into GSK Keyman once again. This time, we're going to open our database. So we're going to select option 2. And the database name, allcerts.kdb. And it's asking for that password that you will never, ever forget. Uh-oh. Ah, whew. Had me worried there for a second. Okay, so I entered the right password and it let me into the database. Now it's going to present you with the main menu again, and I'm going to clear the screen and show you option 5, receive requested certificate or a renewal certificate. When you are first setting up your database with your very first certificate request, that is what you're going to use to satisfy the request. So your certificate is satisfying the certificate request, the certificate that they sent you. In my case, I did not send my request to a certificate authority. I just have a certificate that I have used already in my key databases. So I'm going to use that for an example. Now, I mentioned before you receive anything or before you import anything, you want to be sure to have the CA certificates loaded. So I need to do option 7, import a certificate, because the certificate authority certificates are simple certificates. That's all they are. They don't have private keys. So I use option 7. And the file I saved is called digi_ca.cert. Now it's asking for a label for this certificate. This is more of a title than a label, because labels generally are going to be 1 to 8 character names for a particular certificate. In this case, it's going to be a title, so you know exactly what it is. So if I put in the particular intermediate information for this certificate, specifically as DigiCert Global G2 CA, it imports it, it's done. So back to the main menu. This is where, once you get your root CA certificates loaded and they're in your database, you can now receive your requested certificate. And in my case, I am going to do option 8, import a certificate and private key. Now, in this case, we called it mycert.rec. So it's my certificate request. Uh-oh. What did I call it? This is part of the fun of a live demo, because I thought I called it mycert.cert. Very sorry. Let's try that again. All right, option 8, mycert.cert. Now in this case, this is an exported certificate key, and I put a password on it, so it can't be used if somebody gets their hands on it. I'm going to give it a label, and in this case, I'm going to label it exactly the same as we labeled the request. Oh, because I didn't delete the request. So we will call it sys1 new. Now, if you go back to, for this particular example, I'm going to go into manage my requests and see my old request, and I want to get rid of this because I don't need it anymore. So I'm going to just use option 3 and confirm, and it's now gone. Did that very fast, but I got rid of the request because I want the label of my new certificate and key to match. So if you go into option 1 to review your certificate and keys, you'll see sys1 new. If you select it, you can use option 9 and change that label. And this is important later on. So option 9 and sys1 cert. So it changed the label, now it's good. And I'm going to return to the main menu. So after you validate, you look at your new certificate and key, it's in the database, it's ready to use. You can exit from GSK Keyman, and you can either log off, because you can log off at this point because there really is nothing more to do with GSK Keyman. So I'm just going to go ahead and log off. Now, at this point, we are going to take a quiz. Oops. All right, Sam, if you want to fire up the next quiz. Very good. Very good, everybody. So who's the signer of your certificate? That's the certificate authority. And GSK KYman, Keyman, is the utility for managing your key database. Very good. Now that you have your certificate all set in your key database, you want to be able to use it. So on your system, on your ZVM system, it's through TCP/IP configuration. On your system, your TCP/IP has SSL servers already defined that you can set up to reference that key database. In the CP directory is an entry called identity SSL. That SSL entry is a pool of user IDs that are used to manage secure connections through TCP/IP. That entry, along with the TCP SSLU profile that's used by that identity, that profile contains the POSIX info statement that gives those SSL servers the group name security. And that allows them access to the key database and the saved password file because you set the authority for the group to read. And the group for those files is security. So if you see the alignment there, the authority is set for security group, and the security group is defined for the SSL servers. Generally, you don't need to mess with these settings at all. You just take them as defined. Now you're going to add or confirm SSL statements in your system TCP/IP config file. However, you've got your TCP/IP configured on your system, whichever file has all the TCP/IP configuration statements, that's the one you're going to be working on to add these statements. There are two statements, SSL server ID that defines the timeout, so that the amount of time that TCP/IP will wait to get a response from any SSL server, and the SSL limits of how many sessions maximum and per server that it will allow. So the maximum sessions is a multiple of the maximum per server, if you didn't notice, because you can have by default, 5 SSL servers running. If each one has 100 sessions, that's a maximum of 500 total. You can adjust those as you see fit. And then in the port section of this TCP/IP configuration, you're going to want to add the secure and then the certificate name or label, that parameter to any service that accepts that parameter. For example, this is a web server listening on port 443 over TCP, and I added the secure and then a cert name, which is the label that you've defined for your certificate. For Telnet, for TN3270, there's 2 spots you're going to want to pay attention to. You'll set up port 992 for the internal client in TCP/IP to secure with that certificate name. And you also want to update the internal client parms section to have port 992, secure connection required, and the TLS label of your certificate, the label name. The second file you want to pay attention to is your DTC parms file or configuration file. There's 2 entries in there that you're going to want to have. And these are all defined in the TCP/IP manual, but these are the things that you're going to want to have. And I highlighted specifically portions that you want to pay attention to. The key file entry, the very first entry there, that all certs KDB is the name of my key database that I defined. So whatever key database name you defined, that's what you want to put in there. Now the protocol entries below it, you'll see a plus in front of the TLS v1_2 and then minus for the rest. This is telling SSL, the SSL servers, we will only accept and use TLS version 1.2. TLS version 1.1, 1.0, and the SSL versions are not used and not accepted. Mostly because they've been deemed unsecure now. They're not as robust. So TLS 1.2 is the only protocol that we will accept. We also exempt any low or medium grade ciphers. We only accept and use high graded ciphers. Again, ciphers that's a detailed topic, but this protects and makes sure that we're using the most and highest protocols and ciphers on our secure connections. The second entry is for what's called a DCSS manager. So this is a server, the SSL DCSSM user ID. This is a server that just manages a DCSS on behalf of TCP/IP for the SSL servers. Now, once you have all of that set up, all of your configurations are done for TCP/IP, and your certificate database is all ready to go, this is when you can restart TCP/IP and let those configuration changes take effect. Now, in red letters, this is important. If you've never done this before, don't restart TCP/IP from a TN3270 session, because that's when you lose your session. Your TN3270 session just goes away because you've restarted TCP/IP. So be logged on somewhere else. You can be logged on through the HMC system console, or if you have another way if you have OSA ICC connections, you can do that too. But don't be on a TN3270 through your TCP/IP stack. Once you restart, you should see SSL DCSSM and the SSL servers get started up and running. And you can confirm that with a netstat config SSL and see those SSL servers are active, which active means they're running and listening, waiting for connection. So now your key database is done, your certificate key is loaded, TCP/IP got configured, and the system is now enabled for SSL TLS secure connections. So what that means is if you've secured Telnet, your connections would require port 992. They would require a security setting to be indicated that they're going to accept a version of TLS, probably version 1.2, because it is the most recommended. And then if you have web servers running with the secure cert name, you can now have them answering on port 443, which is the default HTTPS port. And if you have FTP servers, you can also configure them with a TLS label cert name, and those FTP services can also be secured. Now you can validate this through a browser if you've got web servers running. All of the browsers will show you and indicate to you that a connection is secure to that host, and you can see that by clicking on the icon next to the location on the location area, and it will drop down to tell you more about the connection. Whether you're using Firefox or Chrome, you can then click on that and see more details about that certificate. So on the Chrome side, if you see certificate is valid, you can expand on that and see more details. On Firefox, on the very right side, if you click more site information, it's going to also give you details on the certificate. If you happen to see not secure, then you've got a problem. Something didn't get defined completely correctly. There's something going on that you'll have to dig into and figure out. Now, there is a Cert Manager utility that I mentioned early on that is now being provided on your system. The original iteration of Cert Manager allowed you to query your certificates, but the latest iteration of Cert Manager with that PTF that's listed there for ZVM 7.4, that adds management function to your Cert Manager. You can actually do some functions using Cert Manager without having to go into GSK KYman. You can type help Cert Manager for a lot of details on its usage, but it is generally fairly easy to use. So when you use the Cert Manager utility, you could be prompted for the key database password. You just enter the password when it asks you for it. And you can also specify the default key database that you want to use with Cert Manager, so you don't have to keep retyping it, by using the default set Cert Manager database command in CMS. So this is an example of the Cert Manager using the query to see what certificates I have in my certificate database. So you can see the SysOne cert is in my database, and you can see its expiration date that's set and what kind of certificate it is. And then down a little bit farther, you do see the DigiCert Global G2 CA certificate that signed my certificate. And there's also other global root CA certificates and public certificates that are included by default that you see listed. If I do a different kind of query, and in this case, I want to see the chain from my certificate database, it shows you that hierarchy that I mentioned before. It's the global root G2 at the top, my signing certificate in the middle, and my certificate S1 cert at the bottom of that hierarchy. Now let's talk about renewals. You do want to keep track of the expiration date of your certificate. You want to, however you manage your dates and calendar, you want to make sure you keep that expiration date handy somewhere. Because before your certificate expires, you're going to want to create a new request. You're going to want to specify a brand new label for the request. So for example, we've been using SysOne cert as our label. If you had used that yourself, the certificate in your database is labeled as SysOne cert. So the new request, you could name it SysOne renew or SysOne and then the date or something that makes sense to you. But it's going to be temporary. You'll send the request to the CA just like you did before, and the same actions will take place. They will validate it, and then they'll send you a response. You have your new certificate in key. They will most likely send you the exact same intermediate and root certificates that you don't need again but you can use them if you choose to. You're going to import that new certificate into your database using GSK Keyman and option 5, receive requested certificate or renewal certificate. Once you receive it, you're going to have 2 certificate and keys in your database. One's going to be called sys1 cert, that's your original one. The second one, and in this example, we called it sys1 renew. That's the new one. This is the point where you're going to go into each one and relabel them. So you're going to relabel your active one from sys1 cert. Let's just call it sys1 2026. And then select your new certificate, sys1 renew, change its label, and make it sys1 cert. Now that allows you to start using the new certificate with the exact same label of sys1 cert. Why would you want to do that? Because you've had to put that into your TCP/IP configuration. Your TCP/IP configuration files have sys1 cert identified for the secure connections. If you choose to change your label all the time, you have to reconfigure TCP/IP and restart all of those services. But doing it this way, you can keep the label that you've already defined and start using the new one when you're ready. So your key database now contains the original, which is the old certificate that's going to expire, along with the new certificate. Your VM SSL services don't yet have that new certificate loaded. It's in your key database, but the only time the SSL servers look at your key database are at initialization. So it grabs a copy of the certificates when they initialize, and they don't have to reference the key database again until they are reinitialized. So they have the old certificate loaded in memory. To activate the new certificates, you would go to TCP maint, you would enter the SSL admin refresh command. SSL admin is a utility to administer your SSL servers. And refresh is simply telling all of your SSL servers, reread the key database and load the certificates. It does not interrupt any services that are currently connected. So in-flight encryption going on is kept intact. If you want to look at more details on SSL admin, you can just type help TCP/IP SSL admin. But once you enter that refresh, the databases are sent the command to refresh, and you should get back a response basically saying the request was processed, return code 0. At that point, your SSL servers now have your new key and certificate loaded. So any new connections will use that certificate. Now, a little bit more on expiration dates. There has been a lot of discussion around expiration dates of certificates, and it's been going on now for a few years. So the maximum certificate lifespan is going to impact everybody. So before March 15th of this year, of 2026, you could have up to 398 days for the life of a certificate. So that pretty much gave you a little bit over 1 year to have to renew and refresh your certificates. But they've made decisions to change those lifespans for your certificates. As of March 15th of this year, now you can only define a lifespan of 200 days. In 2027, it'll only be 100 days. 2029, 47 days. That means after 2029, you will be replacing your certificate every 47 days or less. Pretty close to about every month, about a month and a half. That means you have to go through that process that I just showed you on requesting a renewal just about every month or so after 2029. If you want to read more about that, I gave you a link that you can go look at more information on that. But this is definitely going to impact all of us. Now, some best practices. The very first best practice is from a lot of security people is that every system that you manage and every system that has data transferring back and forth between it should have their own certificate and key. And that, again, could very well be dictated by your security administration or your CSO. Sometimes it's, the certificates you're building, like I just did in the example, are for a test system or a test system cluster. You might want to load that database, the certificate database, once on one system, and then copy the entire thing to the other members of that test cluster. You can do that. You can get those 3 key database files, send them over to your other GSK admin machines, and then put them into the BFS and refresh the SSL servers on that system. And then you basically, that clones your key database from one system to another. But most security administrators will not recommend that at all, even on test systems. So I'll leave it to you to dig in, if you choose to do that, to dig into how specifically to get the key database files you need, or even just export a certificate key pair to import on another target system if you choose. I highly recommend that you back up your key database. I can't stress this more. If you have a system backup product on your ZVM system, then and it covers the VMsys file pool, then you're probably good to go. Otherwise, you're going to want to set something up to make a backup copy of your key database. You want those, at least you want those 3 main files, the KDB, RDB, and STH files that define and make up your key database. Copy them somewhere other than the BFS so you can get them out of BFS and put them on the 191, for instance. That would be a good start. Or move them off and put them somewhere else. So you could download them, you could send them somewhere else, but have copies of them in case something goes wrong with your key database. Just like losing your password for the key database, if the key database for some reason gets corrupted, and it's rare, but if it happens, you have to start over. And that's painful. It's better to have a backup, and you can restore a backup and get back to some services on that system to some degree, at least. Now, you do want to keep your key database cleaned up. As time goes on, your certificates are going to start collecting. You're going to have old certificates, expired certificates. Using Cert Manager Query Chain helps you see what certificates are expired and which ones you can get rid of. Once they expire, they're not usable anymore anyway. So you can go into GSK KYman, find those certificates and delete them out. So again, doing your due diligence to make sure that they're truly not being used and they're obsolete and they've been replaced with new ones, get them out of the key database because that unclutters that key database and just makes things better. Now, also best practice, self-signed certificates. On the main menu, you may have seen there's an option to create a self-signed certificate. You can do that. You don't have to use a certificate authority, but do not use the self-signed certificates except for very short-term testing. And this is just to make sure, something is actually going to work properly with SSL, because self-signed certificates are absolutely, positively unsecure, and they should not be used for anything other than a really, really quick test. And now you have some homework. On your browser, if you go to our website on https://velocitysoftware.com, I want you to find the certificate information and details and send to homework@velocitysoftware.com the common name of the certificate and the expiration date. And that's it. Do that work, send it to the homework email ID, and we'll check you off and you're good to go. Now, real quick before we end, if you had remembered, I was connected to my system, this test system, on an unsecure connection. And while you were taking your quiz, I restarted my TCP/IP stack. So I'm going to reconnect this session and see what happens. If you note, I got an error. I can't even connect to port 23, which is the default TN3270 port on TCP/IP. It's not even letting me in, because in my configuration, I enabled secure connections on port 992. So we're just going to exit out of this one and open a secure connection, which I did over here. And in this case, I got connected to my system. And down at the bottom left, you see the little lock symbol. And that lock symbol indicates I am secure. It's using a secure connection to my system with a valid certificate. So it's just to show you all those actions I walked through with you actually enabled and set this system up with secure SSL. All right, that is the end of my session. Again, if you have any questions at all, please send them to questions@velocitysoftware.com. And the extra links for getting more information on education and our PDFs for these classes. And if there are any questions pending on chat, if anybody can tell me.
It looks like you have 2 questions related to your content that just got sent in the chat.
Okay. See if I can figure out how to see the chat. Aha. Okay. All right, so can you point me to the first question?
First one was sent at 11:18. Can we view all certificates expiry date?
Yes. Cert Manager is your friend. The Cert Manager utility will actually type out on the console every certificate and the expiration date for you. So Cert Manager is definitely the best way to do it. Otherwise, GSK KYman, the GSK Key Manager utility, you have to go into each certificate and look at the details for each certificate to list the expiration dates. but I would recommend Cert Manager. And the next?
The next one is right below that. I
Okay.
believe digital certificates on ZVM are not taken care of by RACF, and it is created/maintained by GSK KYman. Is that correct?
That is absolutely correct. You're spot on. RACF has nothing to do with your SSL certificates at all. It is all GSK admin using that utility, the GSK KeyYman.
All right, thank you.
Good questions.
I believe that was it regarding your content. So thank you everyone for attending our session today. We will see you all back here tomorrow at 9 a.m. Eastern Time. My team will be staying on just a little bit longer if anyone needs immediate help. Otherwise, all questions can be emailed to questions@velocitysoftware.com. Thank you.